Okay, I've got another example, a third example on creating a VBA array function called residuals that's going to fit the data to a line. So I've got some XY data here. We have the independent variable X, which is along the X-axis here, and I've got Y data. So this would be experimentally observed data. We're going to fit the data to a line using the slope and intercept functions in Excel. Then our array function is going to calculate something known as the residuals of all the data points. And then it's going to output those residuals, the residual vector, back to Excel. Y is the observation. That's the Y value of the observation. So those are the blue markings. We have the line of best fit, which is the blue dotted line here. The slope is M, B is the y-intercept, and y hat here in y hat equals mx plus b is the predicted value based on the equation for the line of best fit. So we're going to use the Excel functions for slope and intercept to calculate m and b. We can then calculate the predicted value for each value of x here. We have a total of 9 of those. Then what we're going to do is we're going to create something known as the residuals for each of those 9 different points. The residual for each point, the residuals are just the difference between the prediction and the observation. And then that's what we want to output then as a vector. We're going to have 9 of these as a column vector. We want to output that back to Excel. So I'm going to draw a flowchart for this. We start. The first thing we're going to do is we are going to import the data. So I'm going to define a data array. It's going to be an n by 2. The first column is going to be the x values. The second column is going to be the y values. I'm also going to keep track of the things that we need to dim over here. So data is something we're going to need to dim. And we're going to dim that as a variant. Whenever you just say data equals arranged, for example, you need to dim that vector or array as a variant. Next, we're going to count rows. We're going to store that in a variable n. N is going to be an integer. Next, we're going to redim, and we're also going to have a couple more vectors in here, which I will define in a little bit, but we're going to redim all vectors. One of the vectors we're going to create is just going to be the x values. Then we're also going to create the y values, so we're going to extract the first column from data and define that as our x vector. We're going to extract the second column of our data array and define that as the y values. These are both going to be doubles. We're going to use a for loop to import the x and y columns from data. The x vector is just the first column of data. The y vector is going to be the second column of the data. So data is just going to be a direct import from the cells on the spreadsheet. When we're done importing all of those values, then we are going to move along and calculate the slope and intercept. We're going to use the worksheet functions, the Excel functions, slope and intercept to calculate m and b. We have to dim a couple more things. After we calculate the slope and intercept, we can go back to our equation. We're going to now use the line of best fit here to calculate a new vector I'm going to call yp for predictions. So that's the predicted value. We're just going to take each x value, we're going to multiply it by the slope and add the intercept to create a vector of predictions. So we're going to enter into a for loop. We're going to iterate through all of the items. We're going to create the yp vector. The next step then is to create a vector of the residuals. We're going to define that as e, an e vector, and that's just the difference between yp and y. So we create e, ei comma 1 equals yp I comma 1 minus yi comma 1. So we're going to get a total of n items. We're going to get n residuals. When we're done with that, the only thing we have to do is we just need to output it. So when we're done, all we're going to do is output, and then we end. A couple other things we need to dim over here. All right, so what this will look like in VBA, we create our function residuals. We're going to have an argument, which is going to be the range on the worksheet. We've got to dim a bunch of things. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 different things that we need to dim, including 1, 2, 3, 4, 5 different vectors or arrays. So I've dimmed my 9 different things. We have I as an integer, n as integer, n is the number of rows. Data, it's a variant. You have to use a variant when you using the technique that I'm doing where you just say data equals range. We dimmed x, so this is the vector of x values, which will correspond to our column of x values here on the spreadsheet. Y is going to be a vector of doubles, so that's going to be equal to our column of y values on the spreadsheet once we do the extraction. Yp is going to be our prediction, m is the slope, b is the intercept, the y-intercept, and e is going to be our vector of residuals. After our dim statements, we have to import the data, we're going to count the number of rows, and then we're going to do all the redim statements. So we can say data equals range to just import this entire range here into the data array. We can count the number of rows of data or range, they're equivalent. Next, I'm going to do all the redim statements. So I've redimmed x, y, yp, and e now that I know the size. The next step then is to import from data all our x vector and our y vector using a for loop. So we implement the for loop and we extract or import the data from, we calculate x as the first column of data, y as the second column of data. Now the next step in the flow chart is to calculate the slope and intercept, and then we're going to apply the slope and intercept to all of our x values to create the y prediction. We're going to then calculate the difference between each y prediction and its observation to calculate the vector e, and then we're going to output that to the spreadsheet. So we can use the worksheet function slope. So there's an Excel function slope where you have your y's and your x's as a vector. Do the same with the intercept, the y-intercept. There's an intercept function, so we can calculate b. And then we enter into the second for loop, where for each I, going from 1 to n, we calculate the predicted, which is just the slope times the x value plus the intercept. Then we calculate the residual for each I, and then the only thing we have to do now is output. And the output of a function is just the name of the function. So I would just say residuals equals e. So I think we're ready to go. I'm going to go ahead and put a breakpoint here, and let's go over to the spreadsheet. So I'm going to type in equals residuals of our XY data, and I'm going to do Control-Shift-Enter, and now I can step through this. So we've obtained data, so I go down here to the locals window. We've brought in all the XY data, and we're going to bring in X and Y, so I can do this a couple iterations. Let me scroll down here. You notice that X is now equal to just the X values of our original data. Y then is equal to just the Y values of our original data. And we can keep going. We use the slope function and the intercept function in Excel to calculate M and B. And then finally we create the predicted values based upon the model. We're creating the residual vector at the same time. So I'm just going to bump out of here, run to cursor. We've created all the residuals. And the last thing is to then take the residual vector E and place that then on the spreadsheet where we typed in the residuals function. All right, and when we do that, then we get the residuals on the spreadsheet. So this is how you could do kind of a more advanced application of array functions. You can now, this is now set up for any column of X and Y data. So hopefully this helped, and I hope you enjoyed this screencast. Thank you.